I'm excited about this one. I've been working several months on this project and finally found the missing link. This 1/4 watt resistor has been holding me back the entire time. A lot of churches have been using their iPhones to stream to Facebook or YouTube because the iPhone's the best camera they have in their auditorium, but their audio has been suffering. So they've been using something like this, adding a micro shotgun microphone, which helps, but it still doesn't give that broadcast audio to the stream. So I've been working on this and finally figured it out. This 1/4 watt resistor has been holding me back from success. So in today's sound advice, I'm going to show you how you can get line level balanced audio from your sound system to your iPhone. We're doing it right now. But before we do that, there's a few things I need to show you about Pro Audio. Before we get to the solution, there's a few things that you need to know. I've scoured the internet looking for solutions to get audio from your sound system into your iPhone and kept coming back with this right here, this little dongle. Can we take a moment and just realize how stupid the word dongle is? But this little dongle has been the answer, or the so-called answer that everybody's been advertising, but it doesn't work. This little dongle allows you to take a microphone and plug it in, but it doesn't allow us to get line level audio into our iPhone. There's other apps that claim they can use this dongle, and they may be able to, but they can use this dongle and you can record a phone call to your iPhone, you can record to your video app, and they even say you can stream, but I haven't been able to get that to work until now. And I'm not using this dongle right here. As I told you before, there's a few things that you need to know about Pro Audio. In Pro Audio, there's 3 main levels of audio. There's mic level, line level, and speaker level. Mic level is right around -50 to -40 decibels. Line level is -10 decibels or +4 decibels. And speaker level is anything from +0 on up to whatever your speakers can handle. Most microphones are between -40 and -50 decibels. We call that mic level. The only time we use mic level in a sound system is from the microphone to the mixing console. As soon as we hit the mixing console, there's a preamp that steps electricity up from -40 to -50 decibels. Now sometimes you'll find -10 dB. That's going to be more in the consumer side, but we're talking Pro Audio. So everything in Pro Audio that we're going to be working with on the outputs, we're going to be working with +4 dB. Once we leave the console, we hit our compressors, equalizers, limiters, we hit the amplifier, and then from the amplifier, we step up the voltage to speaker level, and that goes to the speaker. So we got mic, line, speaker level. The problem is the iPhone's more a mic level input, so we're looking from -40 to -50 decibels. All of our line level outputs on our mixing console is going to blow through and distort that preamp on the iPhone. Also, we need to know about balanced and unbalanced cabling. Now this is just a rough overview. Your typical signal is going to be a positive and a ground. Positive and a minus. That's unbalanced. So this would be an unbalanced signal. If this is 0 decibels on our graph, this is going to be our plus. Our plus sine wave will be something like this, and our minus or our ground will be like that. That's unbalanced. Now balanced has 2 positive signals. One is 180 degrees out of phase. So if that represents 0, our in phase is right there. Our 180 degree out of phase is right there. Plus, we have our negative or our ground. Balanced and unbalanced. Balanced cables are really good for long runs. They help out with RF interference, radio frequencies. They help out with electromagnetic interference, EMI. Unbalanced cables don't work well over long runs. So balanced is the Pro Audio approach of sending line level signals. Consumer is going to be more along the lines of unbalanced. You just have a tip and a sleeve, but a balanced is going to be a tip, ring, sleeve. So in order to make all this work in Pro Audio, we need to be able to send a line level balanced signal from the mixing console to the iPhone. iPhone is mic level input, and it's also unbalanced input. So we got two tasks in front of us. On your typical Pro Audio sound system, you're going to have three different connectors that you'll use that will be balanced audio. This is a Euro block or a Phoenix connector. You have your plus, minus, and a ground. XLR, this is the best mechanical connection, 1/4 inch tip, ring, sleeve. Now, consumer audio would call this a headphone jack or a stereo jack. In Pro Audio, this is a mono balanced jack. So those are the outputs on the sound system. The input on the iPhone is 1/8 inch tip, ring, sleeve. So we need to be able to go from a balanced tip, ring, sleeve to an unbalanced tip, ring, sleeve. The iPhone uses the wiring standard CTAA, plus for the left headphone, plus for the right headphone. The second ring is ground, and then the sleeve is the mic. So we need to wire according to that. So these dongles right here, they have a TRRS, but on the female side, it's only a TRS. The female side is meant for a microphone input, just like this. So this is how we would plug our video micro into the iPhone. But we got one more problem that we need to work around. The iPhone's looking for a resistance that the microphone naturally loads onto the input of the microphone jack. The line level output on the mixing console is not going to show that same resistance or impedance that this microphone is going to show. So if we take our line level audio output and get it into the iPhone's not going to see it. It's going to see it as open, or it's going to see it as a direct short, and it's not going to turn on the external microphone jack. It's going to pull audio from the built-in microphone. So that's where this 1/4 watt resistor is going to fool the iPhone and make it think that when we build our adapter, it's actually an external microphone. So let me show you how you can build this adapter using pretty much everything that you have on hand. The only thing that may be hard to find is this 1/4 watt resistor. Now everything I'm going to use in this build will be noted in the list below. Also, we're going to do a little bit of soldering, and if you've never soldered before, I want you to check out the video that we did, the 6 simple secrets in successful soldering, or 6 secret simple. There's a lot of S's and there's a 6 in there. So anyways, check out the video. Here's the heart of what we're using. This is called a DI box, a direct injection box. The DI is going to do two things for us. It's going to allow us to pad the line level volume leaving the console, and then also it's going to give us a step down isolation transformer. So we're going to be using the transformer from line level to mic level. Now this is what a typical transformer looks like. We've all seen them, and we've got transformers in everything that we use, even how we charge our cell phones. Now I've tried this transformer. This was a transformer I tried, didn't work. This attenuated at 50 decibels, and this is where I finally got down to business. It's an Altec 15095A transformer. These are going for about $75 on eBay right now. A high quality transformer, but you're gonna pay for it. But I wanted to be able to do this job with the DI box. Most churches are going to have DI boxes on hand, so if we can repurpose a DI box for this build, it's going to save you money and allow you to not have to worry about back-ordered items. If you've tried to search for any video streaming of any sorts, you're going to find there's a lot of stuff on back order, and I think it's going to be back ordered for months to come. So this build was so important to me to be able to use everything on hand that you have, except for maybe a 1/4 watt resistor. Now, I couldn't find my package of resistors. It was buried under sawdust here in the shop. So I found our electrical engineer Keith at the church, and he just happened to have some 1/4 watt resistors. We're going to be using 4.7K resistor, but you'll probably be surprised who has some resistors laying around. Also, you can order them online, and I assure you those are not back ordered right now. Let me walk you through how we're getting the audio out of the mixing console into the iPhone. You're seeing my sound come through this mixing console. We're taking an aux out, which is going to be a balanced line level out. We're feeding the high impedance on the DI box. This is about 50,000 ohm impedance. And then we have three options here for pads. We got a 0, a -20, -40 dB pad. After we go through the pad, we hit this transformer. This is a step down transformer. And then we come to the XLR output, which is going to be about a 600 ohm output. And then from there, that's where we insert the resistor. Where we hit the DI box, we're going to come in plus and minus. I'm not going to solder the ground onto this 1/4-inch jack. We're going to use the audio ground on the mixing console. We're not going to bother with loading up the ground on the transformer side and causing some problems. So audio comes in, we hit our transformer right here. Audio comes out through the XLR. Now we're going to wire the XLR a little bit differently. We're going to wire plus on 2, and then our unbalanced, which is going to be our minus or our ground, our unbalanced is going to come in on 3. Now also on 2, this is where I'm going to put the resistor in line. And then we'll zip that to the iPhone using the native iPhone dongle. That's it. It's that 1/4 watt resistor. Now most every church is going to have something like this laying around, and I seriously doubt you use this anymore. This is a tip ring sleeve to a component: video, left audio, right audio. So what we're going to do is we're going to cut this apart. We're going to use this to go into the dongle on the iPhone, and then we're going to solder this onto the XLR. First thing that we need to do is we need to know the pin configuration. So I'm going to use my ohm meter, and I'm looking for, remember, left, right, ground, positive on the microphone. So I'm going to hold my ohm meter to the positive. Now I'm going to go to the tip and start trying to figure out where this is right here. The tip of this red RCA is the positive for the microphone, and ring 2 should be the ring on the RCA, and it's also going to be the ring on the other 2 RCA jacks as well. So now that we know how this thing needs to be wired, I'm going to cut this end off one at a time so I don't lose that red. Okay, so those 2 are gone. I'm going to cut the red off right there. Let's put on our XLR, the rubber boot or bushing, chuck. I'm going to put the insert in the vise. One wrong move and I could burn up the preamp on the iPhone. Now the sound system will be protected from anything that I do wrong from the transformer because it is a isolation transformer. I'm going to cut that tail short, and I'll show you why in just a few moments. Got the ohm meter again. The ohm meter, this is just a voltage meter, and I have it in the continuity setting. So I'm looking for the plus for the microphone, and then just making sure I'm not grounded out, which I'm good. Now I'm going to the second ring. Now I should have continuity on the ground, but not on the positive. Perfect. This is the 1/4 watt, 4.7K ohm resistor. Got my soldering iron ready to go. Tinning the wires. I'm not going to fill the solder pocket on pin 1. As I said before, I'm just using pin 3 and pin 2. My resistor is going to go in line on pin 2. I'm going to cut off the tail of that resistor, put a little solder on it, and I'm going to solder on the positive conductor. Now you can see why I left the ground longer. So now I'm going to solder the ground in. But this is a little fancy wiring. This is where you typically put the negative or the black conductor instead of the ground or the shield. Carefully slide the strain relief and bushing up. And I now have a tip ring sleeve to XLR. This XLR will now go in the DI box, and then this goes into the iPhone. It is literally that simple. These parts aren't back ordered. You probably have a DI box at your church right now. You don't have to worry about buying special apps to make all this work, and it's going to work with our pro audio requirements. This is our unbalanced signal. We want this as close to the phone as possible. We want to run the longer balanced line cable to the phone. So if we're placing the phone up close to the preaching area, then we run a long line level cable that's balanced to the DI box. The DI box sits right next to the phone. You can do the line level side unbalanced, but if that's the only option that you have, make sure that everything's next to the mixing console, because again, any long runs of unbalanced audio is just an open gateway for RF or electromagnetic interference to come into your signal and ruin your streaming mix. Thanks for watching. I'm Jude, and this is my sound advice.